left-hand side, what is that the equation of? Who can tell me? Let's talk about that for just a second. Yes? That is the ellipse. How do you know that that's an ellipse? It's the standard equation. Okay, fair enough. What else do we know about that ellipse? It goes left and right. Yeah, the major axis is left and right. Yes? The vertex is the center. Good. We know lots of things about that, right? So here's what I have. I kind of have this picture drawn for you already. You don't need to copy this. Just sort of look and pay attention and see what happens. So over there, up here in this sort of area, right, you can see I have the equation of what we just were talking about. But notice, why does the picture look circular? Who can tell me why? Who thinks they know why? Why does the picture look circular to you? Yeah, Ian, what do you got? He says because a squared and b squared are equal. Is that true? Okay, so if I increase a, what would you expect the graph to do if I increase the value of a? I see people shaking their head, going this. So how can we describe that? A stretch horizontally, so more oval, right? So if I increase my a value, look what happens to the graph. You're absolutely right. It increases left and right. It has the eccentricity of it, right? Increases. Okay. So let's bring this back to 1 here. Go to discrete values. What about b? What would you expect to see? Up and down, right? If I up and down. Now, what if b was negative?
It's absolute value.
Wait, absolute value? I don't see absolute value anywhere. It's squared, so what does that mean? Molly? Would it be a hyperbola if b was negative? Let's see. Oh, no, we still have an ellipse. Why? Because it's squared. What happens right here? What happens there? If b is 0, right, so y squared over 0 is bad. Thou shalt not divide by 0, right? And we end up with this funky line thing going on, right? Okay, so here's what I want to show to you. If I have the plus sign in between my x squared over a squared plus y squared over b squared, if I have the plus sign in there, I get this circle, which we can translate then into an ellipse. Feel good about that? What if I take it away? Whoa, then what do I get? 2 tree trunks. Yeah. Don't I get some kind of a rational function here? I'm multiplying x squared over a squared times y squared b squared. So I get this beautiful looking graph, right? Like a star, right? Okay, now what happens if I move the a? Whoa, kind of like increases and then it goes down to nothing again. Why does it go down to nothing? Because you can't divide by 0. And notice there's a little circle at the 0. Very interesting things going on there, right? And then same thing if I do the b, right? Sort of gets bigger and smaller. So we'll reset these back to 1. And that's what I would get, right? So if I have the plus sign in between the x squared and the a squared, y squared, b squared, I get a circle or ellipse, depending on how I choose a and b. If I take the plus sign away and I multiply them, I get this beautiful sort of rational function going on. If I put a minus sign in between them, notice all of a sudden I get a hyperbola, the last one. So these are all so closely related, and in fact the ellipse and the hyperbola are so closely related that if I just make the minus sign a plus sign, then I get the ellipse. I'm all messed up here. Get rid of, where's the dot? I don't even see the dot on here. Do you guys see it? There we go. How's that? There we go. So I go from that just to that by making the signs different, right? And again, if I increase the a and the b, look what happens to the hyperbola. Whoa, it goes away. Why does it go away? Good, you guys catch it on. So check it out. So the a sort of increases it sort of left and right there in this particular case. What happens with the b? Watch this. Yeah, look, it's almost like wings flapping again, right? Yeah. Yeah, so we can have like a really narrow hyperbola, or we can have sort of a very sort of wide shaped hyperbola. So these take different shapes. And the asymptotes of the hyperbola are what characterize that shape. So let's go back and talk about all the parts of the hyperbola here now that we've seen a little bit of it. Okay. So if you have this picture on your page, we have a center. We're going to start off with the center, of course, at 0, 0. So that's going to be my center. All right. Similarly, like the ellipse, it has 2 vertices, except the vertices are closer to the center than the focal points in the case of the hyperbola. So I have 2 vertices. I have 2 focal points which are beyond the vertices. So now they're further away from the center. And then I have this sort of up and down part that we need to talk about that creates what I call this box here. So what we have are some distances that we need to define, and this box helps us do something. So first things first, let's go ahead. The distance from the center to a vertex is still going to be called A. We're not changing that at all. Just like it was in the ellipse, right? The distance from the center to a focal point is still going to be called C. We're not changing that at all either. And the distance from the center to the top of this box is what we're calling B. It doesn't really have a name, or not one that I can remember at this moment, but that's just how it is. Now, do you remember the relationship between the ellipse for C, A, and B? Yeah, if I'm going back over here in the ellipse category, we had C squared was A squared minus B squared. Notice that the signs were different. So, what would the relationship be for the hyperbola then? C squared has to be A squared plus B squared, which is basically the Pythagorean theorem, right? Okay, what does this box help us do? Here's what it does for us, all right? What it does is it draws the asymptotes. The asymptotes are a part of the hyperbola. So what we're going to do is we're going to go from the center to the top corner of our box, draw a line up and out. And then center to the bottom left, draw the line down and out. And then do vice versa. So center to the top left, up and out. Center to the bottom left, it's bottom right. Now, what those do is tell you how wide or narrow the hyperbola is. And the thing that goes along with the hyperbola are these asymptotes. So this has an equation to it. Y equals, let's see here, it's a line. So we can figure out the equation of a line. What's the slope of this line? How far up did we go? No, don't think in terms of numbers. Think in terms of letters. B, how far over did we go? A, so what's the slope of that line? B over A, x. Good. What's the slope of this asymptote? Well, how far down do we go? No, how far down do we go? B, how far over do we go? So it's negative B over A. The transverse axis, right? So the last thing that we need to put on our graph is the transverse axis, which goes right through the focal point, the center, and the vertices. So that tells me that we have a left-right transverse axis. Weird. Let's just do that. Oh! Sorry about that. Here's the equation. That's what I was looking for, you guys. Okay, so we have y squared minus, what we're going to do. Sorry about that little confusion. Yeah, we're going to put it into standard form, so we're going to divide everything by 4 so we can figure out what it is that we're actually working with here. So I've got this. I've got y squared over 4 minus x squared over 1 is equal to 1. Right, I know a lot of information now about this particular equation. First of all, I have a hyperbola, don't I? Because I have a minus sign between the two. Right? Second of all, is it an up-down hyperbola or a left-right, and how do you know? Yes, this is an up-down transverse axis. And how do we know this part again? Because the y is the one that's positive in this case, or the 4 is the one that's positive, and it's underneath the y. Good. What is the value of a squared? 4. Very good. So that means a has to be plus or minus 2. What is the value of b squared? 1. So that means that b has to be plus or minus 1. And the value of c squared, well, we know these are related by adding them together. So 4 and 1, so I'll just do a squared plus b squared. So c squared has to be 5, so c has to be plus or minus the square root of 5. Like this, the best I can. All right, so we're going to start by putting the center on our graph. So our center we know is at 0, 0. We know that the a distance, and we have an up-down, so we're going to go up to 2 and down to 2. So there's my vertex, and there's a vertex. B, I go left and right 1 unit, so I'll go left and right 1 unit, and that is enough to draw the box. So you draw the box first before you can get the asymptotes and everything involved with that. All right, since we know it's an up-down transverse axis, I'm going to put in an up-down transverse axis here so I know that I'm going up and down. Okay, focal point is the square root of 5. How much is the square root of 5? Like 2.8? Really? 2.23. So, okay, so we're going to go up 2 and then a little bit more. So there's a focal point, which is at the point 0, comma, square root of 5. The other focal point is down here, which is at 0, comma, negative square root of 5. All right, great. Now I can draw my asymptote. So I start at the center, go up to the top right and out, center, top left and out, center, top right, or bottom right and bottom left. So what is the equation of these asymptotes? Well, I know that y has to be, I went up how much? I went up 2 and then over 1, right? So y has to be 2 over 1x. And I can do plus or minus for the asymptotes. You can also pick that up on the cheat sheet that I gave you, right? It tells you which one is which and where it goes with. All right, and then you've got everything you need to draw the picture. So staying within the confounds of those asymptotes there, hopefully yours looks way better than mine does right now. I'll just do it and you guys can take a look and see. So we're going to divide by 36 first, right? Is that what you guys did? Sweet. So I get x squared over 4 minus y squared over 9 equals 1. All right, is it up, down, or left, right? Yeah, this is the left, right? Just because the 4 is positive underneath the x, so that's my transverse axis. Yeah. A squared is 4, so that means A is plus or minus 2. B squared is 9, so B is plus or minus 3. C squared is A squared plus B squared, so C squared is 13. So C is plus or minus square root of 13. 3.6? Okay. All right, and then let's graph it. Here we go. Ooh, what are the equations of the asymptotes here? That's the only thing we need. So y equals, we can go plus or minus 3 halves x. Okay, here we go. Center, 0, 0. Transverse axis, left and right. So that means I need to go 2, 2, 3, 3. There's another box. Oh, yeah, it is left and right. Hold on a second, dude. All right. Hey, Riley, what's the focal point? 2.6? 3.6? 1, 2, 3.6? So 1, 2, 3.6. So the focal point is going to be square root of 13, comma 0. And the other one is negative square root of 13, comma 0. All right, there you go.